Hi, welcome to Orozco's Lectures. I am Jose Orozco, and these are my lectures. This lecture is a Calculus 2 lecture. I hope you enjoy it. Alright, this is Chapter 8, Section 5, so 8.5. And 8.5 is called partial fractions. Alright, so in here, well, first let's get the general idea. Alright, and the general idea is that we can take a fraction, right, like 3/4, and we could rewrite this as a sum of other fractions where the denominators are factors of the original denominator, right? Similarly, if I look at 7/8, this would be something like 1/2 plus 1/4 plus 1/8, right? Um, we can also have things like 5/6, which would be 1/2 plus 1/3, right? Where these are all factors of 6. Something like 2/9, where it's 1/3 minus 1/9, right? Or that was a 2. Or something like 5/12, which is 1/2 minus 1/12, right? So these are, again, this is just the general idea of what partial fractions is, that we can take a fraction and rewrite it as a sum or difference of partial fractions, right, of the original fraction, where all the denominators are just factors of the original denominator, all right? So that's the general idea that we're doing with this partial fraction method. So here we go. This is how to actually find those kinds of fractions. So we're going to call this the composition of n of x over d of x, all right, into partial fractions. All right, so, and that's what this is called, partial fraction decomposition. All right, so the very first thing we want to do is we want to divide when improper. What do we mean by that? So if the degree, I missed a letter, if the degree of n of x is greater than or equal to the degree of d of x, do long division first. Do long division first. All right. So if the degree of the numerator is greater than or equal to the degree of the denominator, we have to start with long division. All right. The next thing we want to do here, we want to have denominator factors. So we're going to factor the denominator. All right. And we're going to factor it as much as possible. And it is important that it is factored as much as possible, all right? In other words, everything must be linear or quadratic. Quadratic. All right. So all the factors must be either linear or quadratic. And they can be to repeated powers, but they must be linear or quadratic, and they must be non-factorable. So maybe I'll say that too. Linear or quadratic and non-factorable. All right. And the next thing is, well, for the linear factors, right? So for linear factors, we're going to say for each factor of the form px plus q to the m, and this is for the denominator, right? For each factor in that form, the partial fraction decomposition well, that's not how you spell decomposition. There we go. The partial fraction decomposition must include the following sum of m factors. And they would be as follows. They're going to be a sub 1 over px plus q plus b, well, I'll call it a again, plus a sub 2 over px plus q squared plus a sub 3 over px plus q to the third, so on and so forth until we get to the mth power. So a sub m over px plus q to the m. All right. So notice here that with this m here, there's this m here. So again, so for every for every linear factor that's of that form to raise to the m power, we have to have these many fractions. So if it was to the first power, well, we would ignore all of this, right? And we would just have this piece. If it was to the second power, we would have these two pieces. If it was to the third power, we would have these three pieces, so on and so forth, right? In here, a sub 1, so where a sub 1 represents a constant. And let's just say a sub I, because it's not a fixed number. All right. So that's for linear factors. All right. So now let's talk about quadratic factors. But I'm gonna copy a lot of this just so that I can edit and be lazy when it comes to writing this. All right. So this is going to be for quadratic factors. And this is going to be the fourth rule. So instead of linear, we're going to say quadratic factors. For each factor of the form, well, that's not going to be the form anymore because that's not quadratic. We need it to be quadratic. So for each factor of the form, and I'll write it as ax squared plus bx plus c to the n, the partial fraction decomposition must conclude the following sum of n fractions. Ooh, this should say fractions, not factors. Let's fix that. And I guess I have to fix it up here too. Yep. This should say fractions. All right. So it must think so back to the quadratic factors. It says for each factor of the form of ax squared of the quantity of ax squared plus bx plus c to the n power, the partial fraction decomposition must include the following sum of n fractions. And there will be the following. So b sub 1x plus c sub 1 over ax plus ax squared plus bx plus c plus b sub 2x plus c sub 2 over ax squared plus bx plus c squared plus b sub 3x plus c sub 3 over ax squared plus bx plus c to the third, so on and so forth until we get to not a b sub n x plus c sub n, all of that over ax squared plus bx plus c to the nth power. All right. And where b sub I and c sub I represent And by constants, we mean, like an actual real number, all right? Not a variable. So that's the general idea, all right? This is for linear factors. Again, if we have a linear factor raised to the m power, we must have m fractions where we are increasing the power of each of them by 1. Similarly, for quadratic factors, if we have ax squared plus bx plus c to the n power, we must have a fraction for each of those powers where they are increasing by power. All right, so let's do a couple of examples. All right, and let's say that I have the integral of 5 over x squared plus 3x minus 4 dx. All right, the very first thing I'm going to do here is, well, the degree on top is smaller than the degree on bottom. All right, good. So I don't have to worry about the long division, but I do have to worry about factoring the denominator. So I have 5 over, this factors out to be x minus 4, no, excuse me, x plus 4 times x minus 1. I don't know where I got that 3 from. X minus 1. There we go. X plus 4 times x minus 1. And dx. So what I'm going to start off with is I want to rewrite this fraction. So I've got 5 over x plus 4 times x minus 1. And for each of these factors, well, they're both raised to the first power. So I'm going to write it as a over x plus 4 plus b over x minus 1. Notice in here I'm using a and b instead of a sub 1, a sub 2. All right, that's just so that we don't have to worry about the indices on all those a's. All right, and here we can just go ahead and use two different letters. So now, the next thing I'm going to do here is I'm going to multiply both sides by this denominator, x plus 4 times x minus 1. At that point, what do I get? I end up with the equation of 5 is equal to a times the x plus 4 cancels out, so x minus 1, and b times x plus 4 because the x minus 1 canceled out. At that point, what we want to do is solve for the variables. All right. Now, there's two ways to go ahead and solve this. All right. First, I'll do the longer version, and it says, well, let's expand this right-hand side. All right. So perhaps I'll do this in two different colors so you can see the two different versions. So version 1. So expand the right-hand side. So I have 5 is equal to ax minus a plus bx plus 4b. The next thing we want to do here is we want to group these up on the right-hand side based on their variable. So I really have 5 is equal to, well, here's an x and here's an x. So I'm going to have a plus b x. All right, so I'm factoring out the x out of both of those two, plus, and then whatever we have remaining, negative a plus 4b. All right, at that point, we're going to say, well, on both of these sides, we've got polynomials. All right, the only way that two polynomials can be equal to each other is if their coefficients of their respective variables are the same. So on this side, there's essentially an invisible 0x plus 5, right? That's what makes these two, this side a polynomial as well. So what we can say here now is that, well, 0 is equal to a plus b, and also 5 is equal to negative a plus 4b, all right? And notice the reason why we're able to do this is because, again, we're setting this 0 equal to this a plus b, and this 5 equals to the negative a plus 4b. So from this equation, I get that a is equal to negative b, right? So since a is equal to negative b, I can replace it on this side. So that's going to give me that 5 is equal to the negative of, what was a? Negative b. And then that's plus 4b. So in here I get negative times negative is positive, so positive b plus 4b. So 5 is equal to 5b, which tells me that b is equal to 1, right? Divide both sides by 5. And since b is equal to 1, all right, this is going to tell me now that a is equal to the negative of 1, right? In other words, a is just equal to negative 1, right? So all I did that was plug it into here. And now that I've got both of those, I can say now that this fraction, all right, becomes, well, instead of a, we have negative 1 over x plus 4, plus instead of b, we have positive 1, so 1 over x minus 1, all right? Perhaps I'll make that a little bit clearer. So what we found here is that 5 over x plus 4 times x minus 1 is equal to that. All right, we'll come back to that in a second, but first I want to show you version B, which I find to be a little bit faster than this version. So let's look at version B of how to do this, or version 2, I should be saying. So version 2. And let's remind us what we had. We had 5 is equal to a times x minus 1 plus b times x plus 4, right? And here, well, this equation, if I want to solve for a and b, this equation needs to be true for any value of a or b that exists. I mean, for any value of x that I want, all right? So let me repeat that. This equation must be true for any value of x, because x is a variable, right? And it should be true for any value of x. So let's see what happens when x is equal to 1. When x is equal to 1, well, this equation becomes 5 is equal to, well, a times 0, right? 1 minus 1 is 0, plus b times 5. At that point, I get 5 is equal to 5b. Therefore, b is equal to 1. And notice that I chose that 1 because it was going to make this 0. So similarly, to make this part over here 0, I'm going to let x be equal to negative 4. And let's see what happens when we do that. On the left side, I have 5 is equal to a times, well, negative 4 minus 1 is negative 5. And then that plus b times negative 4 plus 4 is 0. Good, that's what we wanted. So now I get 5 is equal to negative 5a, so that a is equal to negative 1. At this point, I can say that my original fraction, which was 5 over x plus 4 times x minus 1, is going to be equal to negative 1 over x plus 4 plus positive 1 over x minus 1. All right. Now, I personally find this second version quicker than this first version, but there are some scenarios where this version number 1 is the only way to do it. All right. We'll talk about a scenario like that later on. But all right, so now that we have this, well, that tells us now that the integral of this thing, well, you know what? I don't know. Let's just go ahead and continue this in a different color. So, all right, so now we can say that this integral of 5 over this stuff dx will be the integral of all this stuff dx, right? And now at that point, well, in here, these are both technically a u substitution, but I'm going to go ahead and say this becomes just negative ln of the absolute value of x plus 4 plus ln of the absolute value of x minus 1, all right, plus c. And that's a good enough final answer. If you really wanted to, you can rewrite this as ln of the absolute value of x minus 1 over x plus 4, but you don't have to. You can leave it as this line right here, all right? All right, so let's do another example. So example B. So I have here the integral of 1 over x squared minus 9 dx. So the first thing I see here, well, let's factor this. So this factors out to be 1 over x plus 3 times x minus 3 dx. So now I have the fraction of 1 over x plus 3 times x minus 3. And I want to set this equal to now a over x plus 3 plus b over x minus 3. And multiplying both sides by the common denominator, by this denominator over here. All right, what we get here is 1 is equal to a times x minus 3 plus b times x plus 3, right? All I did there was multiply both sides by this stuff. At that point, well, I'm going to say, let's do the short version. That's the x equal to 3. When that happens, I get 1 is equal to, this first part goes away. B times 3 plus 3 is 6. So that b is equal to 1/6. When x equals negative 3, to make this part go away, I get 1 is equal to a times negative 3 minus 3 is negative 6. So that a is equal to negative 1/6. At this point, I get that my integral now becomes the integral of, what do we have? A over x plus 3, so that's negative 1/6 over x plus 3 dx. Well, no, let's leave that after. And then that plus b, which was 1/6, so 1/6 over x minus 3, and all of this dx. At that point, we say, well, the integral for these things, these are simple integrals. They become negative 1/6 ln of the absolute value of x plus 3 plus 1/6 of the absolute value of 1/6 of ln. There we go. 1/6 ln of the absolute value of x minus 3, and that plus c. All right. And that's a good enough final answer. You don't necessarily have to combine those. All right. All right. So next one. So that was example B. Yeah. So example C. All right. So let's complicate this up a little bit. Example C. Let's say that we had the integral of x squared plus 12x plus 12 over x cubed minus 4x dx. All right. So again, here the very first thing I'm going to start with is by rewriting this fraction and into the sum of partial fractions. So this is going to be, well, actually, let's factor out the denominator. So this is going to be the integral of, well, that same thing, but the denominator needs to be factored. So we have here, I can factor out an x. So I have x times x squared minus 4x, not minus 4x, just minus 4 dx. And that's going to be equal to, well, let's place that fraction again, but we need to factor out still this region right here. All right. So that x squared minus 4 becomes x plus 2 times x minus 2 and all of this dx. So that's what we have as our denominator. X times x plus 2 times x minus 2. All right, and in here, so again, the very first thing was factor out the denominator. All right, we didn't need to do long division again because the numerator had a smaller degree than the denominator. Okay, so now in here we're going to say this is going to be equal to a over x plus b over x plus 2 plus c over x minus 2. All right, and if I multiply everything by this denominator, I end up with x squared plus 12x plus 12 is equal to a times x plus 2 times x minus 2 plus b times x plus 2 plus c times x times, excuse me, I messed that up. This should be a minus. right? Because we already had the x plus 2. So the x plus 2 cancels out, so we're just left with the x and x minus 2. This is the one that gets the x plus 2. All right. So that's what we end up with. And again, what I'm doing there is I'm multiplying both sides by this piece. Therefore, in the first one, the x cancels out. The second one, the x plus 2 cancels out. And the third one, the x minus 2 cancels out. So at this point, again, I'm going to do the short version first. So let's start making some of these zeros. So if let's start with x equals 0. Notice that x equals 0 is going to make this piece and this piece go away, right? So if I let x equal 0, on the left side, I'm just left with 12. On the right side, I end up with 8 times 2 times negative 2, right? I'm just plugging in 0 into here and there. And again, this part goes away, this part goes away, because x is 0, and I'm multiplying by 0 there. All right. So I get here 12 is equal to negative 4a, so that a is equal to negative 3. Cool. Next one. Let's make this a 0 now. So I'm going to let x equal negative 2. What do we get? Well, on the left side, we have negative 2 squared plus 12 times negative 2 plus 12 is equal to, on the right side, well, if I'm plugging in negative 2, this part makes it 0, so that is going away. This part makes that 0, so that is going away. So I'm just left with b times negative 2 times negative 2 minus 2. So, right, so let's see what we got here. Negative 2 squared is positive 4. 12 times negative 2 is negative 24, and then we're adding 12. On the right side, we have b times, well, this part right here, negative 2 minus 2, is negative 4. Negative 4 times negative 2 is positive 8. So now, 4 minus 24 is negative 20. Negative 20 plus 8 is negative 8. So negative 8 is equal to 8b. So that b is equal to negative 1. Cool. So that's when x was negative 2. Now when x is positive 2. When x is positive 2, this part's going to go away because of this region. This part's going to go away because of that region, right? Those become zeros. So when x equals positive 2, what do we get? On the left side, I have 2 squared plus 12 times 2 plus 12, right? On the right side, what do I get? We already said the a and b's go away. So I'm left with c times 2 times 4, right? 2 plus 2 is 4. So 2 times 4, is 8. So on the right side, I have 8c. On the left side, 2 squared is 4. 12 times 2 is 24, and then we have that plus 12. 4 plus 24 is 28. 28 plus 12 is 40. So I get 40 is equal to 8c. So that c is equal to 5. All right. And now that we have that, we can say, well, then the original integral of this stuff is going to be just equal to, well, we had a, which was negative 3 over, what was a over? A over x. So negative 3 over x. Well, the integral of all this. Plus b, which was negative 1. So negative 1 over x plus 2. Right? And then that plus c, which was 5 over our other factor, which was x minus 2 dx. And at that point, well, this integral is a simple one. This becomes negative 3 ln of the absolute value of x minus ln of absolute value of x plus 2 plus 5 ln of the absolute value of x minus 2, all of that plus c. Right, and if you really wanted to, you could combine all that to be just one fraction, but that is a good enough final answer. All right, next example. So that was C, right? D. Example D. So here we're going to have the integral of the 2x cubed minus 4x squared minus 15x plus 5, all of this over x squared minus 2x minus 8 dx. All right, so that is what we're starting with. Notice there that right away I see that the numerator, it has a higher degree than the denominator. All right, so the very first thing that we do when the numerator is of higher degree is we do long division. So that's the very first thing I'm going to do here, long division. All right, again, it's because the numerator is a higher degree than the denominator. So we've got x squared minus 2x minus 8 into 2x cubed minus 4x squared minus 15x plus 5. All right, so when we do that, well, we say x squared into 2x cubed, well, that's just 2x. And when we multiply 2x into each of these, we get 2x cubed minus 4x squared minus 8 minus 16x, sorry, minus 16x, and then we subtract, right? So again, the way I did that was I distributed this to each of these three, right? So at that point, we subtract. 2 minus 2 goes away. Negative 4 minus negative 4 goes away. Negative 15 minus negative 16, that's negative 15, plus 16, which is 1. So I get x plus 5. And at that point, to go from x squared to x plus 5, it's not doable. So what we get here so far is that this is the integral of 2x plus x plus 5 over x squared minus 2x minus 8 dx. All right. So really, that last part is what you're gonna want to focus on, this over here, because this integral right here is simple, right? So let's figure out what we get for that fraction at the end. So we have x plus 5 over x squared plus 2x minus 8. So let's look at that. So we have that fraction, x plus 5 over x squared minus 2x minus 8. All right, in here, I see that the denominator is factorable, so I have x plus 5 over x minus 4 times x plus 2, right? Negative 4 times positive 2 is negative 8. Negative 4 plus positive 2 is negative 2. So that is going to be equal to a over x minus 4 plus b over x plus 2, right? They're both linear in there to the first degree. So what do I get now? So if I just look at the right side of this dotted thing, and I multiply everything there by this, the x minus 4 times x plus 2, I get that x plus 5 is equal to a times x plus 2 plus b times x minus 4. At that point, we're going to say, well, let's figure out what those are by making some of these things 0. If I let x equal negative 2, well, on the left side, I end up with negative 2 plus 5 is equal to, this part goes away, so b times negative 2 minus 4. Negative 2 plus 5 is 3. Negative 2 minus 4 is negative 6. So I get that b is equal to negative 1/2. That's for x equal negative 2. If x is equal to 4, well, then I end up with 4 plus 5 is equal to 8 times 4 plus 2, right? Because this other part goes away. So 4 plus 5 is 9, 4 plus 2 is 6, so that end up with a is equal to 9 over 6, which is just 3/2. So now I can say that my integral now becomes the integral of a, which is 3/2 over, well, what was a over? A was over x minus 4. And then that plus b, which was negative 1/2, and that's over x plus 2, right? Oh, but we can't forget this piece, that 2x. So let's put that in there. So we gotta get this integral. Let's shift some of this. Oh, that's not what I meant. Wrong tool. So we're gonna shift this over so that we have our 2x in the front of all this. So 2x plus all of that. Well, now the integral of 2x is just x squared, right? It will be x squared over 2 here, but that 2 cancels out. Perhaps I'll write it. So I had this 2 originally from there and then over 2. Alright, plus here this becomes 3/2 ln of the absolute value of x minus 4. And then this next one becomes negative 1/2 ln of the absolute value of x plus 2. And all of this plus c. Alright. So that's what we get there. Next one. So that was D, right? Yeah. E. Oh, and here again, these two cancel out. So it's just x squared. So E. E says the integral of x squared plus 3x minus 4 over x cubed minus 4x squared plus 4x dx. Alright? So here we go. The very first thing there is let's factor out as much as possible that denominator, and I'm going to do it in a different color. So in here, so I have x cubed minus 4x squared plus 4x. I'm going to factor out an x, and I'm left with x squared minus 4x plus 4, which factors out to be x times x minus 2 quantity squared. All right, look at that. We hadn't had that scenario happen before. So let's see what we do with that. So this is going to become the integral of x squared plus 3x minus 4 over this stuff. X times x minus 2 squared dx. And now let's see how we can rewrite this fraction. So in here, this fraction is going to be, well, we're going to set this to a over x plus b over x minus 2 plus c over x minus 2 quantity squared. And I'm going to scroll up for a second just so that you see which rule I'm following there. Alright, so I'm following this rule number 3, right? If I have a linear factor to the m power, I must have that linear factor, that many fractions for that. Alright, so since in this case, in this example, I had it to the second power, I must have 2 fractions with that. Alright, and the top is still just a constant, right? Because the bottom is still just a linear. So what do I get here? If I multiply everything by this common denominator, well, on the left side, I end up with x squared plus 3x minus 4. Now, in here, we have to start being careful, all right? Not so much with this first term. That first one still just is a times x plus, well, I'll write it in the same order, x minus 2 squared, all right? Notice that it's just to the second power because that's what was here, plus b times, this is going to be b times x minus 2, all right? This x minus 2, it cancels out one of these two, but not both of them. That's why there's still one left. And that times c, excuse me, plus c times just x, because the x minus 2 was already there. The x minus 2 squared was already there, right? So at this point, well, let's continue to do the trick of making things go away first. So I'm going to start with let x equals 0. When x equals 0, well, what happens? On the left side, I end up with negative 4. On the right side, I end up with a times negative 2 squared. This piece goes away, this piece goes away. So Negative 2 squared is positive 4, so I have negative 4 is equal to 4a, so that a is equal to negative 1. When x equals 2, well, this piece goes away, this piece goes away, right? So we're just left with that last one on the right. So on the left side, I have 2 squared plus 3 times 2 minus 4. On the right hand, I have c times 2, so I write it as 2c. 2 squared is 4, so I have 4 plus 6 minus 4. So I have 6 is equal to 2c, so that c is equal to 3. All right. And lastly here, well, let's see how we can solve for the other one. There's nothing else that we can do to start making things go away, right? We already used the 2 to make these two go away. We already used the 0 to make these two go away. But there's nothing that I can do to only make these two go away. But that's okay, because we already have some values of a and the values of a and c, right? The value of a is -1 and the value of c is 3. So what we can do here is we can set this equation equal to the following. So x squared plus 3x minus 4 is equal to, well, a was -1, so I have -1 times x minus 2 squared. B we don't know, so b times x minus 2 plus c we do know is just 3. So I get 3x. And now at this point, what we need to do is solve for b, right? So the way that I'm going to do this is I'm going to expand everything on the right as much as possible. All right, let's expand everything on the right. So I have the negative of x squared minus 4x plus 4 plus, I'm going to treat both of these as one thing, so I have bx times x is bx squared, bx times -2 is -2bx, and I have that plus 3x. Distributing this negative, I have -x squared plus 4x minus 4 plus bx squared minus 2bx plus 3x. All right, and on this side I still have dx squared plus 3x minus 4. The next thing I'm going to do on the right side is I'm going to group them by powers of x. So I'm going to have something here with an x squared. Now let's look at what has an x squared. All right, and I see that I have an x squared here and an x squared there. So what I have here is -1 plus b plus. Let's group the stuff that has just an x. And what I see is I have an x there, I have an x there, and I have an x there. So that gives me 4 minus 2b plus 3. And then we're going to pair up the constants. -4. That's the only constant, -4. And again, this is equal to x squared plus 3x minus 4. So now, now that we have them grouped up in this way, what we can do is, well, make the coefficients of each of those powers of x the same, right? So in other words, I can say 1 is equal to -1 plus b, right? That's for x. For x squared, we get 1 is equal to -1 plus b, so that b is equal to 2. Let's see if that is consistent with what we have on the rest of this. For just x, we've got that 3 is equal to, well, 4 plus 3, there is 7. So 7 minus 2b, all right? And if I subtract both sides by 7, 3 minus 7 is -4. So -4 is equal to -2b. Divide both sides by -2. 2 is equal to b. Good. We're consistent. And as far as the constant goes, let's make sure that we still get the true thing. -4 is equal to -4. Good. Good. So at that point, well, let's see what we get with this, because now we've got the value of b. So we've got the value of a, the value of b, and the value of c, right? So now this integral, the original integral, which was, did I copy it? I did. Look at that. So we have the integral of this stuff, dx, is going to be equal to integral of, well, what do we have? We had a over x, and a was -1. So now we have -1 over x plus we had b over x minus 2. So b was 2. So we've got 2 over x minus 2 plus then we had c over x minus 2 squared. And our c was 3. So we have 3 over x minus 2 squared, and all of this dx. All right. So now let's see how to integrate each of these. All right. So in here, I'm gonna write this as three different integrals. The integral of -1 over x dx. Well, that's just negative ln of the absolute value of x plus c. The integral of 2 over x minus 2 dx. Well, that's just 2 ln of the absolute value of x minus 2 plus c. This last integral, the integral of 3 over x minus 2 squared dx. Well, this actually requires a u substitution. So if I let u be equal to x minus 2, then du is equal to dx. So I end up with here the integral of 3 over u squared du, right? X minus 2 is our u, dx is our du. So I'm going to write this as 3u to the negative 2 du. Adding 1 to the exponent gives me u to the negative 1, dividing by the new exponent, so over -1 plus c, but the problem was not about u. So we have here, I'll write this as -3 over, right? I'm doing it over because this negative exponent goes to the bottom, over x minus 2 plus c. So that gives me now the overall final answer of negative ln of the absolute value of x plus, well, the x plus c we can just do at the end. Negative ln of absolute value of x plus 2 ln of the absolute value of x minus 2, and then that minus 3 over x minus 2 plus c. All right, and that would be my final answer for this example. Example E, right? That was E. Yeah, good. So F. So here I'm going to say let's have the integral of x squared minus 1 over x cubed plus x dx. This is really just saying x squared minus 1 over x times x squared plus 1 dx. All right. Notice again that this is not a scenario that we had dealt with before, because now we've got a quadratic in there. All right. So a non-factorable quadratic in the denominator. So now let's see what we do here. So again, I'm going to start by saying, well, let this fraction here equal to, let it be equal to a over x plus, look at this, this is now a quadratic. When we have a quadratic on the bottom, well, we need to set a linear on top. So I have it as bx plus c over x squared plus 1. All right. The next thing I'm going to do here is I'm going to multiply both sides by this common denominator. So I have x squared minus 1 is equal to a times x squared plus 1 plus bx plus c times x, right? So now let's see, is there anything that we can plug in to make stuff go away? Well, yes, we can plug a 0 into there. So if x is equal to 0, well, what do we get? On the left side, we end up with just -1. On the right side, because this is 0, that part completely goes away. Because this is 0, I just end up with a. So I have the value of a is -1. Cool. So what does that do for us? I'm going to plug that in here and see what we get. All right, so I have now x squared minus 1 is equal to negative of x squared plus 1 plus, if I distribute this out, I end up with bx squared plus cx. All right, so I really have x squared minus 1 is equal to negative x squared minus 1 plus bx squared plus cx. All right, the next thing I want to do is I want to pair these up based on um, degrees of x. So I'm going to have here something x squared. And where do I have the x squares? Well, there's 1, there's another 1, so I have negative 1 plus b plus something x. Where do I have the x's? Right there, and that's it. So I just have c plus the constant, which was just negative 1. So plus negative 1. And the next thing we're going to do here is set um, the corresponding coefficients equal to each other. So if I look at x squared, well, in here on the left side, my coefficient was 1. On the right side, my coefficient was negative 1 plus b. So add 1 to both sides, I get that 2 is equal to b. For x, on the left side, the coefficient of x is 0, right? There's no x's there, so it's 0. On the right side, the coefficient of x is c. So I get that c is equal to 0. And then for the constant, that's just constant somehow. Notice that we have negative 1 and negative 1. Good. All right. So that tells us that we're consistent. So now that we've got the values of a, b, and c, we can go ahead and rewrite this fraction, right? So what we can write here is the integral of this thing, dx, is going to be the integral of a. A was negative 1, and we're going to put that over x. So negative 1 over x plus b x plus c, but c is 0, so I'm just going to put it as 2x over x squared plus 1 dx. So in here I've got two integrals, so let's look at each integral separately. The integral of negative 1 over x dx, that's just negative ln of the absolute value of x plus c. Excuse me, the other integral. So in the other integral, I have the integral of 2x over x squared plus 1 dx. And here, if I let u be equal to x squared plus 1, then du becomes 2x dx. So that this integral becomes the integral of, well, that 2x dx, that's just my du. And that denominator of x squared plus 1, that's just my u. So I end up here with just 1 over u du, which ends up being ln of the absolute value of u plus c. But the problem was not about u, so we have ln of the absolute value of x squared plus 1 plus c. Combining both of these answers, we get our final answer of negative negative ln of the absolute value of x plus ln of the absolute value of x squared plus 1 plus c. And if we really wanted to, we can rewrite this as ln of x squared plus 1 over x plus c, right? So that is example F. Let's kick it up a notch. Example G. All right. This is G. And here we've got the integral of x squared over x to the fourth minus 2x squared minus 8 dx. All right. So that's what we're starting with. So the very first thing I'm going to do is, well, let's factor out that denominator. If you notice here, I have it in quadratic form. So because I have that in quadratic form, what I can do here is I can rewrite this now as the integral of x squared over. So because it's quadratic form, I can factor this using the following way. So we're going to have this x squared minus 4 times x squared plus 2. All right, so essentially I'm treating that as if it was just a general quadratic because it's in quadratic form, dx. But in here, this x squared minus 4, that is still factorable, right? We have to make sure to factor it as much as possible. So it's the difference of squares, which is why I have x plus 2 times x minus 2. All right. Now, what we're going to do here is we're going to say, well, let's copy this fraction. All right, so this fraction now is going to be equal to, well, let's see what we can do. It's going to be equal to a over x plus 2 plus b over x minus 2 plus cx plus d over x squared plus 2. Right? That's going to be my setup there. And now we need to see, well, let's multiply both sides of this equation by this entire denominator. So when I multiply the left side by the denominator, I'm left with just x squared. When I multiply on the right side, I end up with a times, well, the x plus 2 cancels out. So I have x minus 2, that's 2, x minus 2 times x squared plus 2. Plus, with b, we have the x minus 2 is going to cancel out. So we're left with x plus 2 times x squared plus 2 plus cx plus d times the x plus 2, the x squared plus 2 is going to cancel out, so I'm left with just this piece over here, x plus 2 times x minus 2. At that point, well, let's see, can we plug stuff in to make things go away? Yes, we can plug stuff into here and into there, right? So let's see, let's start with that x equal 2. Right? And when x equals 2, well, what do I get? On the left side, I end up with, well, just 2 squared. On the right side, if x is equal to 2, this goes away, as well as this entire thing, right? Because that makes this 0 and that part 0. So I'm left with just the b part. So I have b times 2 plus 2 times 2 squared plus 2, right? So that's what I'm left with inside there. And I guess this is in parentheses. All right. 2 squared is 4. 4 plus 2 is 6. So I have on this side, well, on the left side, 2 squared is 4. On the right side, 2 plus 2 is 4. 2 squared plus 2, we just said that was 6. So that tells me if I divide both sides by 4, that 1 is equal to, so I'm dividing both sides by 4, so 1 is equal to 6b. So that b is equal to 1/6. All right. That's when x equals 2. Let's see what happens when x equals negative 2. And notice that when x equals negative 2, well, this part right here goes to 0, so that goes away. This part right here goes to 0, so all that goes away. So I'm just left with the a portion. So on the left side, I have negative 2 squared is equal to just the a portion, so it's going to be a times negative 2 minus 2 times negative 2 squared plus 2. Negative 2 squared is 4. And here I have a times negative 2 minus 2 is negative 4. Negative 2 squared is positive 4 plus 2 is 6. Dividing both sides by 4, I end up with 1 is equal to negative 6a. So that a is equal to negative 1/6. All right. And now we solve for a and b. So now let's see. Is there anything that we can do to make sure that this piece and that piece go away? Well, unfortunately, there is not. There's nothing to make both of those go away without making the last term, without making this part over here go away. So that means that we're gonna have to expand the right-hand side, but with these values. All right. So let's plug in a and b. So what do I have here? What I have here now is that x squared is equal to negative 1/6 times x minus 2 times x squared plus 2 plus b was 1/6. And we have that times x plus 2 times x squared plus 2 plus, we don't have values for c or for d, but I'm going to go ahead and distribute these two. All right, I'm going to expand that. So x plus 2 times x minus 2 is x squared minus 4. All right. So now, um, let's see what happens here. Now, the first thing that I see here is I've got fractions. All right, and I'm trying to solve these things, and I don't want to have to deal with fractions in the middle of all this. So the very first thing I'm going to do here is I'm going to multiply both sides here by 6. All right, and I multiply by 6 to get rid of these fractions. So what I get here is, so again, I'm taking this entire equation and I'm multiplying by 6. So what do I get? On the left side, I get 6x squared. On the right side, well, the 1/6 and the 6 cancel out, so I have the negative of x minus 2 times x squared plus 2 plus the 1/6 and the 6 cancel out, so I have x plus 2 times x squared plus 2 plus, well, I need to add a 6 here, so 6 times cx plus d times x squared minus 4. All right, so at this point, we need to distribute as much as possible. All right, so let's see what we get here. I'm going to leave this negative alone, but I'm going to distribute this x minus 2 with this x squared plus 2. So at that point, we're going to say, well, x times x squared is x cubed, x times 2 is 2x, negative 2 times x squared is negative 2x squared, negative 2 times positive 2 is negative 4. Next one, distribute this x plus 2 into this one. So x times x squared is x cubed, x times 2 is 2x, 2 times x squared is 2x squared, and 2 times 2 is 4. Next one, leave the 6 alone. Let's distribute those. So cx times x squared is cx cubed, cx times negative 4 is negative 4cx, d times x squared is dx squared, and d times negative 4 is negative 4d. All right. At that point, well, let's see what else we can do here. Let's distribute everything out. Let's get rid of all the parentheses. So I have here negative x. So I'm distributing this negative, right, into here. Negative x cubed minus 2x plus 2x squared plus 4 plus, and here these parentheses aren't doing anything, so we can just write everything without worry. And let's distribute the 6. So 6c x cubed minus 24cx plus 6dx squared minus 24d. All right. So that's all equal to just 6x squared. So now let's group the right hand side by the powers of x, by different degrees of x. So here's what we're gonna do. So we have something here with x cubes. So I have a negative x cubed plus x cubed plus 6x plus 6cx cubed. All right, so we have negative x cubed. Excuse me. I'm going to write just the coefficients. Negative 1 plus 1 plus 6c. All right. Notice that the negative 1 plus 1 cancel each other out, so we just have 6c. All right. Now let's look at the stuff with x squared. I'll do that in a different color. So we have here, there's an x squared, there's an x squared, and there's an x squared. So what we have here is 2 plus 2 plus 6d. All right. So notice that's essentially you're saying 4 plus 6d. So I'll write this as a 4. All right. Plus, let's see the stuff that has just x. And we'll do it in red. So in here we have this has an x, this has just x, this has just x, and that's it. So we have -2 plus 2 minus 24c, right? And that was with x. Notice there that the -2 plus 2 just cancel each other out, and we're left with just -24c. And now, lastly, we'll just do the constant. The constant, well, the stuff that doesn't have anything underlined. So 4 plus 4 minus 24d, because that doesn't have a variable, right? And 4 plus 4 is really just 8, right? So now that we've got that, I'm going to set equations here based on the degrees of x. So if I look at x cubed, well, on the left side, right, on the left side, all I had was just 6x squared. So there's no cubes, so that means that 0 is equal to 6c. So that tells me that c is equal to 0. Cool. Next one, let's see. We had 4 plus, so that's for x squared. For x squared, we have, well, on this side I have a 6, so 6 is equal to 4 plus 6d, right? And this subtract both sides by 4, end up with 2 is equal to 6d, so the d is equal to 1/3. Good. Now let's look at just the coefficient of x. On the left side, well, there wasn't anything with just x, so that's 0. On the right side, I have a -24c, right? Because -2 plus 2 cancel out. That's just 0. So dividing both sides by -24, I end up with c is equal to 0, which is good. That's what we had over here too. Good, at least we're consistent. The last thing that we have here now is the constants, right? On the left side, we had no constants, so 0. On the right side, we have is equal to 8 minus 24d. So let's solve. Add 8 to both sides. Actually, you know what? I'm going to add 24d to both sides. So 24d is equal to 8 divided by 24. So d is 8 over 24, which reduces to 1/3, which is good. That's what we had gotten before, so we are definitely consistent, and we can be pretty sure that our numbers are correct. All right, so now, at this point, well, what does that give us? Well, what we get now is that the integral of this stuff, dx, can be written as the integral of, let's see, we had a over x plus 2, and a was -1/6, so I have -1/6 over x plus 2, plus, what else do we have? We had b over x minus 2, and b was +1, so b over x minus 2, b was 1/6, so I have here 1/6 over x minus 2, plus, well, what else did we have? Cx plus d over x squared plus 2. But our c was 0 and our d was 1/3. So cx, that would be 0x. We're not going to write that. So it's going to be 1/3 over x squared plus 2 and all of this dx. So let's see what we get here. I'm going to look at these as 3 different integrals. So the first one, I'm going to rewrite it as -1/6 integral of 1 over x plus 2 dx, which gives me -1/6 ln of the absolute value of x plus 2. The next integral, I have 1/6 integral of 1 over x minus 2 dx. So that's going to give me 1/6 ln of the absolute value of x minus 2. And I forgot to do the plus c. That's okay. And the last one, I have 1/3 integral of 1 over x squared plus 2 dx. I am going to rewrite that integral as 1/3 integral of 1 over x squared plus radical 2 squared dx. And that integral should look very familiar. That integral is arctan. So what I have here is now 1/3 times 1 over a, which is radical 2, arctan of u, which is x, over a, which was radical 2. And all of this plus c. All right? Now, in here, this 1 over 3 radical 2, right? That really becomes just radical 2 over 6, all right? So this is just radical 2 over 6. So my final answer here is going to be, well, the sum of these three is going to be negative 1/6 ln of the absolute value of x plus 2 plus 1/6 ln of the absolute value of x minus 2 plus radical 2 over 6 arctan of x over radical 2, and all of that plus c. All right, and there's many more examples that we can do. All right, but I'm gonna end the video there. So that was 8.5, which again was partial fractions. All right, wasn't that fun? If you think I made a mistake somewhere, you're probably right. Tell me all about it in the comments. If you feel you learned something from me in this video, hit the like button, hit the subscribe button, but more importantly, share it. Share this video with your classmates. And remember, you don't have to like math in order to be good at it. But you do have to be good at it. I am Jose Orozco. Goodbye.